Hello and welcome. In this video, we'll go over the key do's and don'ts for using LightWare sensors. From mounting and heat management to communication setup and safety, these tips will help you avoid common mistakes and get the best performance. Let's get started. Mounting sensors behind glass or perspex can affect how the laser signal travels and reflects. Using the wrong materials or setup may lead to inaccurate readings or signal loss. These are the do's and don'ts to look out for to ensure clear and reliable signal transmission. Don't use non-optical materials or thick screens that distort signals. Don't mount the sensor where objects or reflections can interfere with the laser path. Don't leave large gaps between the sensor and the screen without adjusting the angle. Use optical-grade glass or perspex that is translucent at 905 nanometers. Keep screen thickness between 1 to 2 millimeters. Apply an anti-reflective coating to reduce signal interference. Enable last pulse detection for better accuracy. Use 962 PMMA perspex for best optical performance. In scanning setups, position the sensor close to the dome or use a splitter to bring the beam to the surface. Choose a mounting spot clear of obstacles or reflective surfaces in the beam's path. Mount the sensor flush against the glass to reduce distortion. Angle the screen 3 to 10 degrees if there's a gap to reduce reflections. The direction your sensor faces plays a big role in how it collects data. Whether you're scanning terrain or avoiding obstacles, proper orientation helps maintain accuracy and responsiveness. These are the do's and don'ts to follow to ensure your sensor is aligned for optimal performance. Don't mount the rangefinder inside the airframe cavity. Don't allow the beam to pass through recessed areas. This can cause beam divergence. Avoid setups that can create false short-range readings or trigger out-of-range conditions. Mount downward facing for altimetry, terrain following, or precision landing. Use a 20 to 45 degrees angle to reduce reaction lag at higher speeds or when there's system delay. Mount forward-facing for sense and avoid or position hold applications. The orientation of the sensor does not affect the performance of the sensor. Moisture and water exposure can damage sensors or interfere with their operation. Proper mounting and environmental awareness are key to keeping your sensor safe. Here are the do's and don'ts to help you protect your sensor from water-related issues. Don't submerge sensors. Only the LW20/C is fully IP67 rated for temporary submersion. Don't install sensors in areas where standing water can accumulate. Don't ignore pressure or temperature changes. They can cause water ingress if improperly mounted. Mount sensors so only the IP67 rated lenses are exposed. For LW20C, ensure correct installation to maintain dust and water protection. Prevent water from pooling around the sensor. Sensors generate heat during use, and without proper cooling, this can lead to malfunction or reduced lifespan. These are the do's and don'ts to help you manage heat and keep your sensor running smoothly. Don't enclose the sensor in a space without proper airflow. This can lead to overheating and malfunction. Don't overlook thermal management, especially in enclosed or high-temperature environments. Ensure the sensor has adequate ventilation to allow heat dissipation. For open units like the SF20C, GRF 250, and GRF 500, use a thermally conductive pad on the heat sinking area. How you connect your sensor matters. Incorrect cabling or handling can lead to communication errors or even damage. Here are the do's and don'ts to ensure safe and reliable sensor connections. Don't connect to the peripheral system before attaching the sensor cable. Don't ignore ESD precautions when working with exposed units. Connect the cable to the sensor first, before plugging into your system or computer. Handle open units, such as the GRF range or SF20 with care. Protect them from static discharge. Electromagnetic interference can disrupt sensor signals and reduce accuracy. Shielding and grounding are essential to prevent this. These are the do's and don'ts to help you maintain clean signal transmission. Don't leave the shielding cable unattached to protect signal integrity. Do provide EMI shielding where necessary to protect signal integrity. Improper grounding can cause electrical noise, communication failures, or even damage. Here are the do's and don'ts to ensure your sensor is safely and correctly grounded. Don't create ground loops, as they can introduce electrical noise. Don't allow floating grounds. A voltage difference can cause communication failures, damage components, or pose fire risks. Don't overlook grounding requirements. Proper grounding is critical for safe and reliable operation. Do use a separate power supply when required by your system setup. Ensure a common ground between the sensor and the host system. In setups where multiple sensors share a communication line, I2C addressing ensures each sensor can be uniquely identified and properly managed by the host controller. Misconfigured addresses can lead to communication errors and system instability, especially in complex builds. These are the do's and don'ts to ensure smooth multi-sensor communication and avoid address conflicts. Don't give multiple sensors the same I2C address. This will cause communication errors. Don't assume the default address will work in all setups. Check and configure as needed. Do assign a unique I2C address to each sensor on the bus. Ensure the host controller is configured to match the sensor's address. Update the controller settings when changing a sensor's address. Use I2C when connecting multiple sensors to a single communication line. LightWare sensors automatically switch between communication modes like serial, I2C, but require the host controller to communicate with the sensor on startup for it to switch between serial and I2C. These are the do's and don'ts to ensure your sensor starts up in the right mode and communicates properly with your system. Don't change the sensor's startup mode to I2C if you plan to use it with USB adapter. Don't assume the sensor will auto-switch protocols without the correct startup communication from the host controller. If this is not set up correctly, there will be no communication from the sensor. If you plan to use a USB adapter, always keep the start mode setting on wait for interface or serial. Only switch the start mode to I2C if your flight controller specifically requires it. If you need assistance changing the startup mode, please contact support. Note that this change can only be made through code. LightWare sensors use eye-safe lasers, but basic safety precautions are still important. These are the do's and don'ts to help you handle laser components safely. Don't look directly into the laser output, even with the naked eye. Don't use a magnifying glass or any optical aid to view the laser. This can make it dangerous. Don't assume eye-safe means risk-free under all conditions. Remember that LightWare sensors are eye-safe under normal use. Do handle the sensor with care and follow basic laser safety guidelines. Dust and dirt buildup on the sensor lens can affect how well it performs. While cleaning is important, it needs to be done gently to avoid damaging sensitive parts. These are the do's and don'ts to look out for to keep your sensor clean and working accurately. Don't use harsh chemicals like acetone, brake cleaner, or paraffin. Don't apply pressure or use abrasive materials that could damage the lens surface. Don't neglect lens cleaning. Dust buildup can affect accuracy. Clean the lenses periodically to maintain performance. Use a dry, soft cloth to gently wipe the lenses. Only use isopropyl alcohol if chemical cleaning is absolutely necessary. Sensors contain sensitive electronics. Mishandling can lead to damage or inaccurate readings. These are the do's and don'ts to help you handle your sensor safely and correctly. Don't disassemble the sensor. It contains sensitive electronics vulnerable to static damage. Don't attempt reassembly. It can cause misalignment and lead to inaccurate readings. Don't forget, disassembling the device voids the warranty. Using multiple sensors on the same target requires proper spacing and configuration to avoid signal confusion. Here are the do's and don'ts to ensure accurate multi-sensor targeting. Don't mount sensors too close together looking at the same target. Don't mount the sensors such that the sensors' beams overlap. When mounting multiple sensors on the same vehicle, angle the sensors away from each other such that the beams do not overlap. Use sensors with first and last return capability to detect multiple surfaces when appropriately spaced. Sensors exposed to vibration need secure mounting to prevent long-term damage or performance issues. These are the do's and don'ts to help you stabilize your sensor and reduce mechanical stress. Don't install the sensor loosely or in high vibration areas without proper support. Don't ignore mounting stability. Even minor vibrations over time can cause issues. Mount the sensor securely to avoid exposure to excessive vibration. Use a vibration dampening material at the mounting point to reduce mechanical stress. Understand that while the sensor can tolerate vibration, long-term exposure can affect electronics. Thanks for watching. Following these do's and don'ts will help you protect your sensor, improve accuracy, and ensure long-term reliability. If you need any support, please feel free to reach out to the LightWare support team, who will gladly assist with your query.